In this video, we're going to be talking about antiderivatives. Now, what are antiderivatives? Antiderivatives are the opposite of derivatives, so they cancel each other out. So if I was to do the derivative and then the antiderivative, I should end up with the original function. Or if I do the antiderivative and then the derivative, I should end up with what I first started out with. Okay? So what's the objective? The objective is to find the antiderivative of a function using the power rule for integration. You also have to find the antiderivatives of the 6 trigonometric functions, the exponential functions, and logarithmic functions. Now, the derivative finds the slope. The antiderivative will help us find the integral, or in this case, the area underneath the curve. Now, what is the antiderivative? I already said it's the opposite of finding the derivative. So let's look at the power rule. The derivative of a times x to the n, what I would do is I would multiply my power to my coefficient, so I'm going to get an, and then I subtract 1 from my power. So basically there's 2 steps. Multiply the power to the coefficient to get the new coefficient, and then subtract 1 from the exponent to get the new exponent. Now, the antiderivative is actually going to be the opposite of these 2 steps. Now, don't do the opposite of step 1 and then step 2. You actually have to do it in reverse order. We're going to do the opposite of this guy and then do the opposite of this guy. So the first step, instead of subtracting 1, we're going to add 1 to the power to get the new power. And then finally, instead of multiplying, we're going to divide the coefficient by the new power to get the new coefficient. So the antiderivative of this right here is going to be, I have n minus 1, and what I'm going to do, let me write this down here, a times n times x to the n. So what I'm going to do is I'm going to add 1 to my power. And then this right here is my new power, so I'm going to divide it by n minus 1 plus 1. Well, n minus 1 plus 1 is just going to give me n, so this guy and this guy reduces, so I'm going to be left with x to the n. Down here, this guy reduces to 0, so I really have a times n divided by n, which is a. So this is what I really started off with, and if I look at it up here, sure enough, I'm looking at it and I have the exact same thing that I have down here. Okay, so what are the rules? All right, let me restate it again. Add 1 to the power to get the new power. All right, and then finally, step 2, divide the coefficient. You're going to divide the coefficient by the new power to get the new coefficient. Okay? Alrighty, so let's look at some of these examples here. So, Mr. Quintana, I'm going to add 1 to this guy, so I'm going to end up with x to the 3rd, and then I'm going to divide my coefficient by the new power, and that is going to be my antiderivative. So this is the antiderivative of this, but I'm going to put a plus c, and let me go ahead and explain that since I'm already here. Why do I put a plus c? Because there might be a coefficient in there somewhere who, when I take the derivative of this, is going to give me that. Okay, so for example, let's say I have 5/3 x cubed plus 7. So when I take the derivative of this, I'm supposed to get that, and the derivative of this is that, because the derivative of 7 is 0. Or I could have had 5/3 x cubed minus 2, and the derivative of this is going to be 0. So we don't know if there's a constant out there or not, so we're just going to put plus c. So what happens if my power is a negative? It's the same rule. So what we're going to do is we're going to add 1 to my power. So what negative 3 plus 1 is going to be negative 2. I'm going to divide my coefficient by the new power. So that's going to give me negative 4 x to the negative 2 plus c. So this is the antiderivative of number 2. So how do you check your answers? The great part about antiderivatives is you can always check your answers. So let's take the derivative of this. What is negative 2 times negative 4? That's going to give me positive 8. And then I subtract 1 from my power. Negative 2 minus 1 is negative 3. Yep, checks. And the derivative of any constant is 0. Perfect. So in the last scenario, I'm going to add 1 to my power. So I'm going to get x. And I'm going to say 2/5 plus 1 is really 2/5 plus 5/5. So I'm going to say 2/5 plus 5/5. And that's going to give me x to the 7/5. Now I'm supposed to divide by 7/5. But I have 1 divided by 7/5. So I'm going to go back to middle school and I'm going to say, all right, what's 1 divided by 7/5? Well, they taught me when I was in middle school that now they have the new math. I have no idea. 1 times the reciprocal of 7/5. So it's going to be 5/7. So that's going to give me 5/7. So this problem is going to be 5/7 x to the 7/5 plus c. And this will be the antiderivative of this. Okay? So we did the antiderivatives using the power rule. So it's power rule for integration. Now, what you need to understand is there's a couple of things that are going to be very easy to think of. All right, so the integral of any number is just going to be ax plus c because the derivative of ax is a. In this scenario, you're saying, oh my gosh, those are the trigs. Well, when we did the trigs, there is no need to memorize these because all you have to do is ask yourself the derivative of what is cosine of x. Well, the derivative of sine of x is cosine of x, and you're done, plus c. In the second scenario, I have sine here. So the derivative of what is sine? Well, it's going to be cosine, but wait a minute. The derivative of cosine, it starts with a c, is going to be negative. There's no negative, so I have to put a negative to cancel the negative when I take the derivative. On the next one, I have a cosecant and a cotangent. So for those of you that saw the video on cosecants and cotangents on the trig derivatives, it starts with a cold squirrel and a Christmas tree, so I need another cold squirrel. But there's no negative, so I'm going to put a negative to cancel out the negative that's going to appear when I take the derivative of this function. And then the next one, I have secant tan. Well, the derivative of what is secant tan? Well, I need another secant, so it's going to be the secant x plus c. Now, what happens if I have 2 secants? Well, I'm lacking that tree, right? 2 squirrels and I need the tree. So the derivative of tan is going to be secant squared x plus c. Okay, tan of x plus c. So now, one more trig, and you're going to say, well, the derivative of what is cotangent? And I think I made a mistake on this one. I'm looking at it. The derivative of what is cosecant squared? It's going to be cotangent, but the derivative of c is negative. There's no negative, so I'm lacking the negative right there. So I'm going to insert it right here. I'm going to insert my negative. So it's going to be negative cotangent x plus c. So I have a little mistake on my PowerPoint. Well, e to the x is the easiest one because the derivative of e to the x is e to the x. So the integration of e to the x is e to the x. Oh, everybody's going to love that. That's one of everybody's favorite. Now, there's 2 more to go. This one is, if you remember, the derivative of square root of x is 1 over 2 square root of x dx. So if you see this, you know that my original function is going to be square root of x plus c. Now, the one that's going to give some students trouble is going to be number 9. That's the only one. And let me explain why. If I was to graph 1 over x, I'm going to have this graph. I'm going to have this graph and this piece. Okay, so ln of 1 over x is made up of 2 pieces. But if I was to graph the picture of ln of x, this is the picture of ln of x. So this is ln of x, and this one over here is 1 over x. Now, what do you notice? ln of x only exists on the right side. It's only on that side. But 1 over x exists that way and that way. There is no ln on this side. There's no ln on this side. So what do? Well, we're going to take the ln of x, and these are negative x values. So what I'm going to do is I'm going to make them positive. So if you notice the curve in here and the curve in here, they're almost identical pictures, except that one of them, well, this one is decreasing and this one is increasing. So when I do it and I do the picture, you're going to notice something. Ready? I'm about to draw the picture of ln of the absolute value of x. It's going to be that piece, and it's going to include this piece. So right here, what do you notice? That my slope is going to be decreasing. So the ln of the absolute value of x. Okay, so by putting the absolute value, you're making the picture appear on both sides. All right. So let's try some examples here. What's the integral of 5e to the 2x? Well, it's going to be 5e to the 2x, right? Because the derivative of e to the 2x is e to the 2x. But wait a minute. This one has a quantity up there. So what's the derivative of 2x? It's going to be 2. So instead of multiplying it by 2 like the chain rule, we're going to divide by 2. And let's not forget that c. So this is going to be the antiderivative of this. So how do you check it? Well, you can take the derivative of your answer. The derivative of 1 is secant tan. Well, I'm missing a secant, x plus c. Now, the derivative of secant is going to be secant tan, and there's a negative here, so that means that I have to put a negative, because the derivative of a secant is positive, and there's not positive, it's minus. All right? Now, this one, when I look at this is going to remind me of 1 over x, dx. And the integral of 1 over x is ln of the absolute value of x. Right? So in this case, my answer is going to be the ln of the absolute value of 5 minus 3x. But now, what's the derivative of 5 minus 3x? The derivative of 5 minus 3x is going to be negative 3. So instead of multiplying by negative 3, I divide by negative 3, and I'm going to add c. And that is going to be the end of the video on antiderivatives. But before I do that, I better do some more problems. Okay, so let's do the integral of 1 over 5 plus x dx, and that one's going to be ln. You got to see it as 1 over u, so it's going to be ln the absolute value of 5 plus x plus c. Now, what's the derivative of 5 plus x? It's going to be 1. So you can multiply by 1, divide by 1, it's going to give you the same thing. Let's try another one. Let's try the integral of e to the 7x plus 5 dx. That one's going to be e to the 7x plus 5. Now, what's the derivative of 7x plus 5? Using the chain rule, it's going to be 7. So instead of multiplying by 7, I divide by 7 plus c. Now, why do I divide? Because when I take the derivative of e to the something, using the chain rule, I multiply it. So on integration, I divide. All right, let's try another one. Let's try the integral of Mr. Quintana. Well, let's pretend I have x to the 5th plus x cubed. And I want you to integrate that. So my answer is going to be x to the 6th over 6 plus x to the 4th over 4 plus c. And let's do one where students have trouble. So then let's try something like integral of x to the negative 3/5 plus x to the 5/11. Okay, so I want you to integrate this one. Well, here what I'm going to do is I'm going to add 1 to my power. So I'm actually just going to take the numerator, add it to the denominator. Negative 3 plus 5 is going to give me 2, and I keep the denominator. So instead of dividing by 2/5, I multiply by its reciprocal, 5/2. Plus, here I'm going to go 5/11 plus 11 over 11. It's going to give me x to the 16 over 11. And then instead of dividing by 16 over 11, I'm going to multiply by 11 over 16, and I add my c. All right, that's going to conclude my video on antiderivatives.